When we look up at the night sky, we see a vast dark canvas. It is punctuated by the brilliant pinpricks of distant stars and the gentle glow of our own moon. It's easy to think of the space between these points of light as nothing at all, a pure, cold, and absolute emptiness. For centuries this was our understanding. Space was simply the void, the great nothing that separated us from the stars. It was a place defined by its lack of things, a silent and unchanging backdrop to the celestial ballet. But this perception, as comforting as it might be in its simplicity, is profoundly wrong. The universe is far more interesting than that. The truth is, the void is not void. It is filled with a richness that defies our everyday senses. It is a dynamic and bustling place, teeming with invisible forces, ancient particles, and the subtle echoes of cosmic history. Far from being empty, deep space is a repository of everything that has ever happened in our universe. It holds the secrets of our origins, the blueprints of galaxies, and the faint whispers of events that took place billions of years ago. It is a library of cosmic proportions, and its books are written in a language of light, energy, and matter that we are only just beginning to learn how to read. Imagine standing in a perfectly quiet room. At first you might hear nothing, but as you listen more closely you begin to notice the subtle sounds. The gentle hum of electricity in the walls, the distant rumble of traffic, the sound of your own breathing. The silence was never truly empty. It was just filled with sounds too quiet for you to notice immediately. Deep space is much like that quiet room. It appears to be silent and still, but it is humming with the energy of creation and the ghosts of long-dead stars. It is a place of profound activity, all happening on a scale so grand it challenges our very imagination. So, as we embark on this journey into the emptiness of space, we must change our perspective. We are not exploring a mere absence of things, we are venturing into a vast, invisible landscape. A place that is not just a container for stars and planets, but an active participant in the story of the cosmos. This essay will be our guide, peeling back the layers of the dark to reveal the hidden wonders within. We will discover that space is not just out there. It is an intricate and watchful presence, and we are an inseparable part of its story. Are you ready to look into the darkness and see what looks back? Let's begin with something we can see, or at least imagine seeing. Light. When you look at the sun, and please never look directly at it, the light you feel on your face has traveled for about 8 minutes to reach you. It is a messenger from the recent past. Now, think about the nearest star to our own, Proxima Centauri. Its light takes over 4 years to cross the immense distance to Earth. When we see it in the night sky, we are not seeing the star as it is today. We are seeing it as it was 4 years ago. The light itself is a form of time travel, a postcard from the past. This simple fact has profound implications. Every star you see in the night sky is a ghost of a past self. The further away the star, the older the light, and the further back in time we are looking. The light from the stars in the Andromeda Galaxy, our nearest large galactic neighbor, has been traveling for 2.5 million years to reach our eyes. That light began its journey long before modern humans walked the Earth. It has traveled through the supposed emptiness of space, carrying a picture of its origin, a snapshot of a galaxy as it was in a truly ancient epoch. Space, therefore, is filled with these light rays, crisscrossing each other in a complex tapestry of history. This means that space itself acts like a vast photographic plate. It is constantly being exposed to the light from every star, every galaxy, every exploding supernova in the entire observable universe. Every event that releases light imprints its story onto the fabric of space, and that story travels outwards forever. If you could somehow stand at a point 1,000,000 light years from Earth and look back with a powerful enough telescope, you would not see our world as it is today. You would see it as it was 1,000,000 years ago, a world without our cities, our art, or our science. The light carrying that image is out there right now, traveling through the void. So, space is not empty, it is saturated with information. It is a gallery of ancient moments, all preserved in the form of light. Every direction you look, you are looking into a different moment in history. The universe is watching itself, recording itself, simply through the act of shining. The light from our own planet, carrying the reflection of our continents and clouds, is streaming out into the cosmos at this very second. It is a silent broadcast of our existence. Could it be that everything that has ever happened in the light is preserved forever, traveling through the watchful void? Now let's think about something more tangible than light. Let's talk about dust. When we think of dust in our homes, we think of tiny particles of skin, fabric, and soil. It's something to be swept away. But in the vastness of space, dust is something far more profound. The space between the stars is not a perfect vacuum. It is filled with incredibly fine grains of dust and sparse clouds of gas. This is not the kind of dust you can see with the naked eye. On average, you might find only a few hundred tiny particles in a space the size of a large concert hall. It is an emptiness of almost unimaginable purity, but it is not absolute. This cosmic dust is incredibly important. It is the raw material from which new stars and planets are born. Within vast dark clouds called nebulae, these tiny grains of carbon, silicon, and other elements begin to clump together under the gentle pull of gravity. Over millions of years, these clumps grow larger and larger, gathering more gas and dust from their surroundings. Eventually, the core of such a cloud can become so dense and hot that it ignites and a new star is born. The planets, including our own Earth, form from the leftover disk of dust and gas that swirls around the newborn star. Our world is made of stardust. This dust does more than just build new worlds. It also affects the light that travels through it. Just as fog on Earth can scatter the light from street lamps, cosmic dust scatters and dims the light from distant stars. It creates a kind of cosmic haze. This is why we cannot see the center of our own Milky Way galaxy in visible light. There is simply too much dust in the way. However, this dust also acts as a kind of filter. It allows us to study the composition of the space between stars. By analyzing how starlight is changed as it passes through these clouds, we can learn what they are made of, revealing the chemical makeup of the galaxy. So, the next time you clean dust from a shelf, remember its cosmic cousin. That empty space is filled with the ashes of ancient, long-dead stars and the seeds of future suns and worlds. It is a celestial nursery and a graveyard, all at once. The very substance of our bodies, the iron in our blood and the calcium in our bones, was forged in the heart of a star and scattered through space as cosmic dust. The void, it seems, is not just watching, it is actively building. Could it be that the dust of space is not just random debris, but a kind of cosmic memory of what came before? Beyond the visible light of stars and the fine motes of dust, space is filled with other forms of light that our eyes cannot see. Imagine you have a special pair of glasses that could see different kinds of energy. If you put on radio wave glasses, the sky would light up with the faint whispers of distant galaxies. If you switch to X-ray glasses, you would see the violent, superheated gas swirling around black holes. Our universe is awash with radiation, a constant invisible glow that fills every corner of space. This radiation comes from all sorts of dramatic cosmic events. Exploding stars called supernovae are some of the most powerful sources of this energy. When a massive star dies, it unleashes a cataclysmic blast that can briefly outshine an entire galaxy. This explosion sends out not just light, but a torrent of high-energy particles and radiation, including X-rays and gamma rays. These signals travel across the cosmos for millions of years, carrying the story of the star's final, violent moments. Even though the event is long over, its energetic signature continues to ripple through space, a ghostly echo of cosmic destruction. Space, in this sense, is haunted by the energy of past cataclysms. This constant bath of radiation has a profound effect on everything within it. It can heat up the sparse gas between galaxies, influence the chemistry of cosmic dust clouds, and even pose a challenge for space exploration. Astronauts on long journeys would need to be shielded from cosmic rays, which are high-energy particles that can damage living cells. This radiation is a fundamental part of the cosmic environment, a constant and powerful presence that shapes the universe on both large and small scales. It is a reminder that space is not a gentle, passive place. It is an active and sometimes hostile environment. This unseen glow is another way the universe records its own history. The radiation filling space is a composite story, a mix of signals from countless different events throughout time. By building telescopes that can detect these different forms of energy, we are learning to read this complex story. We are tuning into the different channels of the cosmic broadcast, listening to the tales of dying stars, colliding galaxies, and hungry black holes. The emptiness is, in fact, shouting with energy. If we could perceive it all at once, would the silent void become a deafening roar? So far, we've discussed things that, while sometimes invisible, are still forms of matter and energy we can understand and detect. Light, dust, and radiation are all part of our known physics, but now, we must venture into a realm that is, far more mysterious. We need to talk about something that actually makes up most of the matter in the universe, yet we can't see it, touch it, or, well, detect it directly in any way. Scientists call it dark matter. It's the great ghost in the cosmic machine, a substance whose presence we can only infer from its effects on the things we can see. The story of dark matter begins with galaxies. When astronomers observed how fast stars were rotating around the center of their galaxies, they found a puzzle. The stars on the outer edges were moving far too quickly. According to our understanding of gravity, they should have been flung off into deep space, almost like children flying off a merry-go-round that's spinning too fast. The visible matter in the galaxy, the stars, gas, and dust, didn't have enough gravity to hold them in their orbits. There had to be something else there, something massive and invisible, providing the extra gravitational pull. This invisible something is what we call dark matter. We believe it forms a vast, spherical halo around galaxies, like a huge invisible cloud in which the galaxy is embedded. It doesn't emit light, it doesn't block light, and it doesn't seem to interact with normal matter in any way except through gravity. It's a silent, unseen scaffold upon which the entire visible structure of the universe is built. Without dark matter, galaxies, as we know them, might never have formed. They would have simply dissipated before they could become the grand spiral structures we see today. This is honestly a truly profound and humbling thought. The universe that we can see, every star, every planet, every nebula, makes up only a small fraction of the total matter that's out there. About 85% of the matter in the cosmos is this mysterious, ghostly substance. We are living in a universe whose dominant component is completely unknown to us. The void isn't just filled with faint traces of things, it's dominated by an entirely different kind of existence. What if this dark matter is more than just a scaffold, but a medium that experiences the universe in a way we can't even begin to imagine? Our final journey into the void takes us back to the very beginning of time. We've seen that space is filled with light, dust, radiation, and mysterious dark matter. But there is one more thing, something that permeates everything, everywhere. It is a faint, gentle glow of microwaves, a form of light with very long wavelengths. It is not coming from any particular star or galaxy. It's coming from every direction in the sky, with almost perfect uniformity. This is the oldest light in the universe, the afterglow of the Big Bang itself. It's called the cosmic microwave background radiation. Imagine the universe in its first moments. It was an incredibly hot, dense, and opaque soup of particles and energy. Light couldn't travel freely. It was constantly being scattered, trapped within the primordial fireball. For about 380,000 years, the universe was a foggy, glowing plasma. But as the universe expanded, it cooled. Eventually, it cooled enough for atoms to form. At this moment, the universe suddenly became transparent. The light that had been trapped was finally set free, and it has been traveling through space ever since, for over 13.8 billion years. This ancient light is the cosmic microwave background. When we detect it with our radio telescopes, we're seeing the oldest photograph in existence. It's a picture of the universe when it was just a baby, a snapshot of the moment of its birth as a transparent cosmos. The tiny variations in the temperature of this light, the little warmer and cooler spots on the map, are incredibly important. They are the seeds from which all future structures, including galaxies, stars, and ultimately ourselves, would grow. They are the first lines in the grand story of cosmic evolution. This echo of creation is perhaps the ultimate evidence that space is a watchful observer. It has preserved the very first light, the birth cry of the universe, for us to find. This light has traveled through the entire history of the cosmos, carrying a memory of the beginning. It tells us that we are part of an immense, evolving story that started long before Earth even existed. The empty void is, in fact, a time capsule of creation itself. As we continue to study this ancient light, what other secrets of our cosmic origins will it reveal to us? Beyond particles and radiation, the universe is structured by an invisible force we are all familiar with: gravity. While we think of gravity as what keeps our feet on the ground, on a cosmic scale, it acts as a master architect. The dark matter we discussed earlier, along with all the normal matter, is not spread evenly throughout the universe. Instead, gravity has pulled it into a colossal, intricate structure that resembles a spider's web. This is known as the cosmic web. It is a network of vast, dense filaments and clusters of galaxies, separated by immense, nearly empty regions called voids. These filaments are like superhighways of the universe, channels along which matter and galaxies flow towards even denser intersections. The clusters of galaxies, some containing thousands of individual galaxies, are the great cities of the cosmos, located at the nodes where these filaments meet. Our own Milky Way galaxy is not isolated. It's part of a smaller group that is, in turn, moving along one of these filaments towards a much larger concentration of mass. The entire structure of the universe on its largest scales is governed by this invisible gravitational scaffolding, a web that stretches across billions of light years. The concept of this web changes how we perceive empty space. The great voids are the most truly empty parts of the universe we know, with far fewer galaxies, gas, and dark matter than average. But they're not nothingness. They're defined by the web that surrounds them. Furthermore, gravity itself can be thought of as a curvature of space-time. Massive objects don't just pull on other objects, they warp the very fabric of space and time around them. So the cosmic web is not just a web of matter, it's a web of warped space-time, a landscape of gravitational hills and valleys. This gravitational structure is another way space records information. The precise shape and distribution of the cosmic web contain a detailed history of the universe's expansion and the interplay between gravity and dark energy. By mapping this web, we're reading a story written in the language of gravity itself. It tells us about the initial conditions of the universe and how it has evolved over billions of years. The silent pull of gravity, acting over eons, has etched the most massive and enduring story into the very shape of the cosmos. Is it possible that even our own small movements contribute, in some infinitesimally small way, to this grand cosmic dance? Among the dust, light, and invisible forces, there is another remarkable component filling the void complex molecules. For a long time, it was thought that the harsh radiation and cold temperatures of interstellar space would prevent the formation of anything more complicated than simple atoms. However, our telescopes have revealed a surprising truth. The vast, cold clouds of gas and dust between stars are actually chemical factories. They contain a rich variety of organic molecules, the carbon-based compounds that are the building blocks of life as we know it. These molecules form on the surfaces of the tiny cosmic dust grains we encountered earlier. These grains act as microscopic meeting places where individual atoms can stick together and react, shielded from the harshest radiation. Over time, this process builds up an impressive inventory of complex substances, including alcohols, sugars, and even amino acids, the very components of proteins. These life-giving ingredients are not unique to Earth. They're abundant throughout our galaxy and likely throughout the universe. The void is not sterile, it's a cosmic pantry, stocked with the raw materials for life. This discovery has breathtaking implications for the possibility of life elsewhere in the universe. Comets and asteroids, which are leftover remnants from the formation of our solar system, are known to contain these same organic molecules. It is widely believed that in the early history of our planet, a constant bombardment by these comets and asteroids delivered both water and these essential organic building blocks to Earth's surface. In a very real sense, the seeds of life may have been sown from space. The emptiness between the stars may have provided the ingredients that eventually led to us. This means that the story of life on Earth is intrinsically connected to the story of the cosmos. We are not an isolated miracle but the result of a cosmic process of chemical evolution that takes place in the dark spaces between the stars. The void is not just a passive stage. It is an active participant in creating the conditions for life. If these ingredients are everywhere, and the laws of physics and chemistry are universal, then it raises an exhilarating question. How many other worlds, orbiting distant stars, might have received this same cosmic delivery? As our journey comes to a close, the image of a dark, empty void has been replaced by something far richer and more complex. We've seen that space is filled with the ancient light of stars, a tapestry of history traveling through time. It is seeded with the cosmic dust that builds new worlds and carries the building blocks of life. It hums with an invisible glow of radiation, the echoes of violent cosmic events. It is structured by a vast, unseen web of dark matter and gravity. and it is permeated by the afterglow of creation itself, the oldest light in the universe. Space is not a passive backdrop, it's an active medium that records, preserves, and transmits information. Every photon of light carries a story. Every cosmic ray is a messenger from a distant cataclysm. The very structure of the universe is a history book written in the language of gravity. In this sense, the universe is constantly watching itself. It's a system of perfect, indelible memory, where the consequences of every event ripple outwards and continue to exist as part of the cosmic fabric. We, as observers, are just one small part of this process, learning to read the stories that have been surrounding us all along. This perspective can change our relationship with the cosmos. We are not insignificant specks in an indifferent void. We are made of stardust, born from a process that began with the Big Bang, and our existence is woven into this grand cosmic story. The light from our sun, reflecting off our planet, is now traveling out into that great repository, carrying the tale of our world. We are contributing our own chapter to the universal library. Understanding this connection is one of the greatest adventures of the human mind, a journey of discovery that expands our sense of who we are and where we belong. The exploration of space is not just about finding new planets or seeing distant galaxies. It's about reading the story of our own origins, written on the largest canvas imaginable. It is an exploration that requires curiosity, ingenuity, and a collective will to look beyond our own small world. By supporting the science that deciphers these cosmic messages, we participate in this grand human quest for understanding. If you found this journey into the Watchful Void as fascinating as I do, I encourage you to share this adventure, for there are countless more secrets waiting to be discovered, out there in the grand and ever-present darkness.